Cool. Awesome. Hi, everybody. Welcome to our event tonight. For those of you who might be joining us for the first time, we are Science Stories. We are a graduate student-run science communication organization at Umass Amherst, and we are thrilled for you all to be here with us tonight. Our speaker this evening is Dr. Christine Hatch. She's a hydrogeologist and extension professor at UMass, working on issues related to groundwater, floods, wetlands, and climate change. And in addition to her research and teaching work, she's been working with communities on issues of sustainable water management. She's active with Girls Inc., and she writes about her work for local newspapers and magazines. So please join me in welcoming Dr. Hatch to be with us tonight.
Thank you so much.
So just as kind of a layout for how tonight's going to work, we have three, we call them vignettes. They're kind of three sections to our night tonight. And first we'll have kind of an intro to our topic, and then we'll have a break for you guys to actually ask any questions that you might come up during that section. And then we'll move into our second section, same thing, we'll have another break for questions, and then we'll have our third and final section. So to kind of open us up, we want to talk a little bit about hydrology.
Sure.
What is hydrology?
Hydrology specifically is the study of water and where water goes, and hydrogeology is the study of water and rocks or earth materials and where water moves around within earth materials. So in the figure that I put up here, it's kind of a summary of a lot of the work that I do in various environments that I work in. And those rainbow areas there are kind of some colorful representations of temperature, and I use temperature to track where water goes a lot of the time in those environments. So I do a lot of work looking at water resources, both for human consumption, but as well as for ecosystems and sustaining ecosystems, and where those human and natural ecosystems interact.
That's awesome. When you were a little kid, did you always dream of being a scientist? Did you specifically have a fascination with water?
Science was always a really good fit, and I don't know if I put that next slide in there. Is that the one I put next? Oh, no, I didn't. Yeah, you can go back. I grew up next to a creek. There was a creek that flowed in my backyard, and occasionally it would freeze over. And when I was about 5 or 6, I went to my very first public meeting to advocate for our river because they wanted to take the nice, clean water that came out of the mountains and divert it into drinking water, which is a good goal. But then they were just going to take this like nasty, yucky lake water and put it in our creek, which we were all really unhappy about. So we went to a water advocacy meeting and spoke on behalf of the river. So that's an early start. And then when I was about similar age, I guess 7 or 8, there was a big flood because we had a really, really big snowpack year that year. I grew up in Salt Lake City, Utah, and there was a really big snowpack that year, and then we had a really, really fast onset to summer, and so the snow melt was starting to flood the entire Salt Lake Valley, and the Great Salt Lake was flooding and coming outside of its bounds and trying to flood the airport. The City Creek, which usually runs forgotten kind of underneath downtown Salt Lake City, sprung its banks and was running right through the middle of downtown, and they asked people to come and put sandbags on the banks of the river that was now running through the middle of town. So that was a pretty marked time in my youth, also because our creek also flooded at that time and ripped out most of the backyard and our neighbor's backyard and the big culvert and the street down below. So I early on started thinking about what happens when our human infrastructure interacts with rivers, especially rivers that are flooding. And all of that came back, the adage, everything I needed to know I learned in kindergarten. Well, that was kindergarten, and so I was learning all about rivers and all about road stream crossings and about how if they're too small or if the river's too big or the flood's really large, then it blows out the infrastructure, and we've got to think about that in different ways.
Yeah, wow. So I feel like this kind of speaks to this a little bit already, but why generally should people care about hydrology and hydrogeology? We've already kind of alluded to some of our infrastructure issues that can come up, but.
Well, water is life. We all need water. All creatures need water. All plants need water. And that would be the most essential element of why we should care about it. But also, as we come into climate change, and I think, yeah, some of these are good examples of this one and the previous one. Here in the valley where we do a lot of farming and other places, we also need food to eat, and all of our crops need water to grow as well. And we used to, maybe there was a time where we used to get this sort of regular small amount of precipitation every single month throughout the year, and that was kind of a normal pattern for quite a long time, which works really well for farming. It's excellent. But that's kind of not the pattern we're in anymore. And both serving on the Water Resources Commission for the state, as well as interacting with farmers around the valley, you really start to see a lot more intense precipitation events that can be really damaging for farms and cause flooding and are really catastrophic. We've had one every other year for quite a few years running now. And then similarly on the flip side, we've seen these really long dry droughts where we have really long dry periods. And coming from Utah, which is a desert state, I was like, nah, Massachusetts doesn't have droughts. But actually Massachusetts has droughts, and it's a big deal when we're trying to grow crops and provide water resources, particularly since, and this is where the geology part comes in, we don't really have the geology to store large amounts of water under the ground. And so if we don't have enough of the surface water resource, that groundwater resource is pretty finite. And so it does squeeze the resource pretty quickly, especially in places where we have larger population centers.
Wow, that is amazing. So, kind of within this whole sphere that we've been talking about in terms of water and water resources, and what exactly are you researching specifically? Like, where do you focus your energy?
I started out doing, maybe click one more. Keep going. Here we go. So actually the day that I arrived in Massachusetts was the day after Hurricane Irene, for those of you who remember that, in 2011. It was kind of a dramatic day, and there was a lot of flooding. And so one of the first things that I started researching when I got here was river flooding, and how do we become more resilient to those river floods. So somewhere in New England there will be a big catastrophic flood every single year, even though the official frequency of those floods is a 1% flood, or once every 100 years. But there's going to be one somewhere in New England every single year. And so how do we think about being more resilient to those and more well prepared for those, and knowing what's going to happen when that river jumps its banks? Did we make enough room for the river to go and flow out onto its floodplain? What's on the floodplain? Oh, did we put a bunch of houses there? Whoops, maybe we should move those houses. Or, things like that. So I got started doing that kind of research. And then more recently, I've been doing a lot of work in the swamp, and we'll probably get to more of that later.
Yeah.
Thinking about wetlands and swamps.
Cool. And what are you most excited about among all of your various projects right now?
Oh, all of them. I like, when I was working on my doctoral dissertation, my advisor said to me, there are lots of bright stones in the river, and you should focus on your dissertation and stop picking up all the bright stones. But I like to pick up all the bright stones, and and for me, each of the topics is really compelling and interesting. And if there's a story in it, or if there's a student project in it, or if there's a way to engage with the public in it, then I'm in it, and I like to do it.
Yeah, that's awesome.
Elise, could you speak up a little bit? The people on Zoom are having a little trouble hearing.
Yes, I sure can. Okay, great. So what's a common myth about your work that exists? And we can take this time to debunk that myth right now.
Oh, fantastic. Well, so one of the first, actually it was the second column that I wrote for the Hampshire Gazette I write for Earth Matters, which is a recurring column in the Hampshire Gazette. It's the Hitchcock Center sponsors. And the second one that I wrote was called "Don't Drain That Swamp," because this whole idea that swamps are bad, and that we use this analogy of a swamp to refer to politics in Washington is a really terrible moniker. So that's the one I'd like to debunk, because swamps are excellent places. They're places where water goes and stays, and it sits there for a really long time, and plants fall in, and there's not a lot of oxygen, and they become really acidic, and then you start to get more plants and more plants and more plants, and that accumulates into carbon. So you probably have heard that there's a bit too much carbon dioxide in the atmosphere. Well, we could put some of that in a swamp and just store it away there happily. And the other thing that it does is once it's in the swamp, it can purify the water that comes through there. And it takes a while, but as long as that water is in contact with all of that organic material, it starts to pull the metals and the contaminants and other things out of that water and leave us nice, clean, fresh water out the other side. There are also places where there's a lot of biodiversity, so there's lots of different kinds of creatures that live in the swamp, and a nice food web, starting from little tiny creatures all the way up to bigger ones that can be rare and endangered. And it's also a place where those floodwaters can go. So when the river overflows, or when you get a lot of water coming somewhere from a storm, if that water has an opportunity to go into a wetland or a swamp, it can slow down and it can spread out and it can spend some more time there. And then when it comes back into the main river, then the main river hasn't risen up quite so much and maybe won't do as much damage on its way down out to sea.
Yeah, that sounds like a lot of really, really good things. Okay, so that kind of brings us to the end of our first section. So that'll open it up to anybody in the audience. Is there anything that anybody would like to ask Dr. Hatch right now? Yeah.
This is probably a stupid question, but what's the difference between a swamp and wetland?
Could you repeat the question?
Yeah.
Yeah, so the question is, what is the difference between a swamp and a wetland? Semantics. I think there might be different, depending on technical definitions. You might call it might be a Venn diagram where a wetland is included in a swamp, or a swamp is included in a wetland, but not much is the short answer.
Well, aren't there other wetlands that are not swamps?
Potentially, there are wetlands that are not
Waters
swamps.
or something like that?
Yeah, I mean, wetland, if you sort of go down to the root of the word, okay, fine, for the linguist in the group, we'll break it up. So it's wetland, and actually wetlands is kind of this interesting, when you start talking about jurisdictions of different areas. Land is governed by all these rules about land and land ownership and land rules, and water and navigable waters that you can sail boats on and row canoes on are governed by another set of rules. And then there was this in-between place that's sometimes wet and sometimes dry and might be squishy and might be just goopy or something. And so that's the wetland, which is sort of in between. And that became really difficult and challenging to, when we started to have land ownership across big swaths of area, then what do we do with these wet places? And that's kind of where that name came from, I think. But then it became, that's part of where this notion of draining the swamp or draining the wetland came from early on, because if we drain it, well, now it's land, and now I can farm it, or I can do something land-wise with it. Whereas I can't quite put a boat on it, I can't really walk through it, it's difficult to navigate otherwise.
We'll start with you.
Just an historical question. New England is a place that when it got going, a lot of sawmills and small dams were set up, and fulling mills and grist mills and so forth. And a lot of the legacy of this damming remains with us. What impact do you think that's had?
Huge is the short answer. So the question is what is the impact of all of the legacy dams on our streams and rivers of various sorts? So grist mills and sawmills and other types of mills and dams that are associated with those. What's the impact of those over time? And it's a pretty large impact. And the impact is twofold, actually, because the first impact is from the deforestation that happened to feed all of those mills. And so you cut down all of the trees, and then you have this bare landscape that is now more prone to erosion. So now you have a lot of material that can erode off those bare hill slopes and find their way into the waterways. So that's one thing that happens. But then they get into the waterways, and it starts to encounter all these small dams. So then all that sediment can build up behind the small dams, actually dams small and large. Sediment built up behind those, and depending on what we were doing at the time behind those dams, if there was an industry or something, or if there was something that was producing a contaminant of any sort, we've gotten better at not doing that, but historically we've done a lot of that. And so a lot of those contaminants and metals and other things are in those sediments that are trapped behind the dams. So the passage for wildlife going up and down the streams, of course, is curtailed by large dams. They can't get past them. Even small dams, they have a hard time getting past. And so for the continuity of the aquatic ecosystems, dams are a really big problem. And also for the ability of the river to respond to floods getting stuck behind those dams. They actually become a public safety hazard at some point if the floods can wash those out. So there's
Should they all be removed?
many of them should be removed. And actually, it's interesting because it's that public safety piece that has been driving a lot of the dam removals, because whoever the dam owner is liable for the damages that could occur if the dam fails. And so they say, hey, this dam either needs to be repaired or removed, and you're liable for anything that could happen. A lot of people will remove it, and that's been great for ecosystems across the region. We have the dubious distinction in Massachusetts, I think, of having the most dams per capita in the density of the state. But maybe that's changing. We've been taking a lot of them out, and the state has programs for priority projects to help remove a lot of those dams. There's a fun one in town in Amethyst Brook where they took out a fairly tall one, and as the sediment was moving its way downstream and clearing out from all the sediment that was trapped behind that dam, they discovered another one that was buried in the sediment that from like the 1700s that was built out of timber. So there are lots of them.
Yeah.
All right, we'll take you in the black shirt, yes.
Are saltwater wetlands different from freshwater wetlands now?
They are definitely different. So the freshwater wetlands, as the name implies, don't have any salty water in them, and they're mostly depressions where water is trapped and caught higher up on the landscape. The saltwater wetlands all occur along the coast. Both of them can store carbon, but in different ways. So the saltwater wetlands, being right on the coast, tend to capture sediment that's some coming from land and that's moving along shore. And there's a relationship between the salt marsh plants as they go up and down and trap the sediment in and around their roots that's trapping some of the carbon in that system. And the saltwater marshes and wetlands are also providing a barrier, a bit of a respite for the storm surge that comes from the coast. So that's another function that they serve that the freshwater wetlands tend not to, just because they're inland. So they both capture stormwater, but one will capture the oncoming wave action stormwater and dissipate the wave damages, and the others can capture the stormwater coming, say, down a stream. Plant communities are quite different. The salt marsh communities tend to be fewer species total, but also a niche group of species that are unusual just because there aren't so many of them.
All right, we'll take one more question. Yeah.
Back to the swamp for a minute. I've read that the Native Americans really prized swamps. And I know part of it was defensive, like building in the middle of it. And I wondered about any other sort of history of like the ecology of the Native American swamp, if you've done any research on that.
Yeah, actually, so we've just got started doing some projects working with the Nipmuc who are around in this area. And you're right, the swamps were definitely defensive because it was this sort of really difficult to navigate place that the settlers didn't follow them into when they went to go hide out in these swamps. But also the Atlantic white cedar tree is a species that's very common in these swamps, but rare and endangered in the state. And that ecosystem has been very important to them. And that tree is used in all sorts of cultural practices that's really important to them. And there's a whole bunch of other plants that are medicinal plants or food plants or other culturally significant plants that are found in those swamps. But the cedars are really one that's very important to them. And that's at the very, very end. Somewhere here you'll see some bits about the Atlantic white cedars. That's what I've been doing most recently.
You might remember if you read Braiding Sweetgrass.
Yeah, braiding
that
sweetgrass,
she brought-
Robin
she
Walker
brought
Murray.
her students to the swamp, which they called Swamp Mart.
Oh, right, yeah, that's right, Swamp Mart, with all the plants and the, that's right.
All right. Well, we are going to move on to our next section, but if you have questions that you still haven't gotten answered yet, don't stress about it. We're going to have some more opportunities, so hold on to your questions and we're going to keep going.
May I ask one question just from Zoom before you?
Yes,
get there?
absolutely.
There's just one question that was on hydric soil areas, and those are also in consideration of wetlands.
Hydric soils? Yeah, so the question is about hydric soils and how that connects to wetlands. And in the strict definition of classifying a wetland, a hydric soil is the type of soil that you find in a wetland, and so it's typically either very clay rich or very organic rich, and they're the types of soils that don't let water pass through them very easily, but that show signs of having been underwater for a long time.
All right, very cool. Okay, so today we're going to talk a lot about some of your work restoring different bogs and different swamps and all of these kinds of things, but we wanted to start with the question of, if you have an abandoned cranberry bog, why can't you just kind of let it go and return to its natural state? Why is that a bad idea?
Yeah, so, well, this, let's see, that's a geology figure a little bit, but if you go forward a couple, I think there's a cranberry, there we go, that's a cranberry bog. So if you look at this system, this is actually the Umass Cranberry Station during harvest time, which creates a really pretty picture from up above. And what you see is that the landscape there is very highly engineered. So you have these berms that are between these square cells, and then each one of those square cells has a deep moat around it. So you have both a moat and a berm on the side. And then in addition to that, you have sand that's applied every 3 years or so to the surface of the bog, because most of the time when the cranberries are growing, it's actually a dry green plant surface and sandy. And the plants don't like it that wet most of the time, but they can tolerate a lot of moisture at some intervals, especially when the plants are dormant. And then you've got all these structures of drainage canals and ditches that are cut throughout it. So there's a couple things that it's a highly engineered landscape, and it's engineered to both allow you to put a lot of water on it and take the water off quickly. And that's not what a swamp does. That's not what a wetland does. You want the water to be there and pond there and stay there for a long time. So the ways in which water leaves the site quickly are through the sand, so the water won't stay on the surface because it'll drain through the sand, through the ditches, drains out quickly, and then through those canals and channels off the site completely. So that takes the water, which there's 3 components to a wetland: the water, the soils, hydric soils, and the plants. And those are the 3 things that define in official terms what a wetland is when you're classifying a wetland. And if you take off that very first, most basic ingredient, the water, then you don't have a swamp. And so what happens, and they've done it, if you just walk away from a cranberry bog, you will get an upland forest, because the surface is so dry, it gets really dry and desiccated on top, and the plant communities that start to grow there are not wetland plants.
Wow, okay. Yeah, that was going to be my kind of follow-up question, is like, what do the succession dynamics look like? Because, yeah, you don't have any water, so if everything is dependent on water, that would mess everything up. So in terms of talking about wetland restoration, how do you determine when it's successfully restored?
Yeah, that's a good question. When you start to get all of those features back, and all the functional features back that a wetland provides. And fortunately for us, in these cranberry bogs, they are built on historic peatlands. They're built on these old kettle hole lakes that filled in with peat, a lot of them. So they already have the hydrology present. The water's already coming in there. They already have the geology underlying it, and they have the peat, which is this hydric soil, underlying it. They have the seed bank from these wetland plants. It's already under there. It's all there. So the hard part is actually already present. The piece that we need to manipulate is what we manipulated in order to make a cranberry farm, out of it and just kind of undo those impacts. And then that landscape just pops back and is functional very quickly. And so a lot of the things that take a really long time to develop, like the hydric soils that can take a century or two to really get into full function, can happen in a couple of seasons. Because you can bring some of that organic material back up to the surface if the water's present. It's like a slam dunk for restoration.
So like 1 year, 2 years?
Well, we're trying to sort that out, actually. So we've got a good working group with the Living Observatory where we've been, a bunch of researchers from around the valley and across the state have been working on trying to identify what are these identifying metrics that really tell us when we're seeing success in those restorations. So as far, I get to work on the easy piece in some ways where the water is, because that happens really quickly. If you put the structures in place and you remove the barriers and you clog up all those ditches that they dug, typically the water levels recover within a season or several months. And so I can see that almost immediately depending on what the action is that they did. So, they put in some plugs in the stream channel to raise the water level, and I see it jump, from one day to the next, and there it is. And then it just kind of stays there, which is pretty cool.
Yeah.
And as long as that water table, the groundwater table, and in this part of the state, so we're talking southeastern Massachusetts and that kind of region, if that groundwater is within about a foot of the surface, then the dominant plant is going to be a wetland plant that is thriving in that environment. And so that's a metric that we can measure, and it's pretty easy to observe. And then within that next growing season, you'll start to see those plants coming back. That's the second component. And so we'll do surveys and go around and see what that looks like. And that's kind of an interesting trajectory, because that'll be, first we'll see a lot of biodiversity come back. All these different plants are like, hey, there's a cool place to grow, let's try it out. And so they go and they start to colonize. And then some that aren't as well suited will start to die back, and you get less diversity with time, but you start to, if it's successful, and we're aiming at this wetland system, you probably see a little less diversity, but you see a concentration of those obligate wetland plants, the ones that are suited to the wetland environment.
Cool. And I would imagine then that policymakers are going to love having all of those metrics. Do you have a way to kind of, I don't know, make them easy to bin so that they can look at that and say like, oh yeah, this is working really well?
Yeah, we have some of that. So the one publication that we put together as a group was the benefits report through Living Observatory, and that's publicly available. You can find it, and when we share that a lot, and that was kind of our best practices of trying to figure out and define what these metrics were, and showcase that. And the next one that we're working on now is trying to come up with what is a reasonable monitoring protocol to keep track of these sites and see how well they're doing. And so measuring the water level, measuring those plants, measuring some of the soil composition, and metrics like that,
Cool.
critters that come back.
So what goes into the decision making about where water should be, especially when you're considering any other land uses like human settlements, any of our agriculture and infrastructure and all of those kinds of things?
That's a really big question. So sometimes I wish that the humans weren't here at all, and we could just, take us off the landscape and let the water go where it wants to go, and then that's where the water should be. However, that's probably not possible. So in that case, we should figure out ways in which we can coexist with where the water is, and ways in which the ecosystem can be healthy and we can be healthy, and where we're not antagonizing each other constantly. So if we take, I think in the River Smart, there was one picture there of Route 100 in Vermont during Hurricane Irene, where the river takes a big carve out of the road. Maybe that's not the best place for that road. Maybe that road is too close to the river. Maybe there's just not enough room for that river to move around where it needs to go. And so maybe that road should be up the hill a little bit further. And maybe we should make sure that that river on the other side has access to its floodplain and its wetland, so it can go and dissipate some of that energy before it comes and tries to eat up our road again. And that way we can live together. And if we're not really building right up to the edge, and the same is true of the coast, if we try to keep going towards the coast and we love the view, and we like to look out at the ocean, and that's wonderful, until we get a big storm or a hurricane or sea levels rising, and then we get another hurricane and it's still higher, and then we're in all kinds of harm's way and we have no barrier, no protection there. And so leaving some of that land and salt marshes or other wetlands or barrier beaches or oyster beds or whatever we have out there to protect us a little bit, then we can both coexist.
Yeah. Does either, like, in thinking about also how our climate intersects in all of this, does the changing or reduced snowpack, or are there other impacts of climate change, like intensity of storms, that are going to impact some of this, affect your work or impact where the water's going to go?
Oh, sure, all of it. So both on the dry side and on the wet side. So in droughts, which we're having more of, we have to think about where are we humans going to get water and store water, and how much of that water is there to go around, how much can we conserve and use wisely, and then are we storing it in surface reservoirs, and then for the ecosystem during those dry times, where are the places where, and this is where the groundwater comes into it, where are the places where the groundwater is naturally coming out of the ground and finding its way onto the landscape? Those places are places where wildlife can go and have refuge during those dry times, where it'll be cooler and wetter, and where they can kind of go and hide out. And then during the wet times, which we'll also have more of, and here in this region we see both an increase in the total amount of water that we get in precipitation over the course of the year. We see that going up little by little in this region, but we also see it, more of it is coming as rain and less of it comes as snow. So you don't get that sort of slow release of the snowpack that you might have gotten in the past. Instead, when you get it, it kind of all happens at once, and then we get a big flood, or that might happen in July, and then we get a big flood when that can happen. And then the way that's connected to the coast, if the sea surface temperature is warmer, and that's true of temperatures, whether it's the air temperature or sea surface or wherever, warm air holds more water, so the exact same storm will have more inches of rain in it. So that same exact storm that we would have had before, if it's warmer, now it's more inches of rain. And so now, instead of being this lovely little trickle that's just tickling the leaves of our crops, now it's actually doing some damage to the leaves, and it's flooding the field, and it's taking some of the soil away with it. And if the sea level has now risen a little bit, that same storm that would have battered the coast just a little bit, well, now it can reach further inland and do more damage.
Yeah.
So all of those things, it's what they call an intensification of the hydrologic cycle that happens, and so you have all of the things we've always had, more so.
Yeah. Wow. Okay. So that brings us to the end of Vignette 2. So opening it back up to everybody else. Yes?
You talked a little bit about ways to coexist. Are there things that people are doing in other parts of the country or the world that would be especially suited to here for coexisting with the water that we can learn from?
Could you just repeat that question as well for folks on Zoom?
Sure. So the question is, what are some techniques that are being used in other parts of the world to coexist with the water and live with the water on the landscape? Yeah, some of the things that I really like for solutions are some green design or green infrastructure is kind of the term that's used for these kinds of solutions. And one of my favorites is what they call a productive buffer. So specifically thinking about farms and river flooding, if you have the buffer between the farm edge and the river, there's a lot of regulations that happen over what you can do in that little stretch of land. But if you have trees with roots that really solidify the bank and they keep the river from having a lot of erosion and migrating around a lot, it's protective of the river, it's healthy for the river ecosystem. But if you can't, as a farmer, do anything with it, you're less inclined to care for it. And so if you could plant, say, nut trees or trees that you might be able to harvest something from, fruit trees or other trees along there, and have sort of a buffer that goes from the crops that you plant annually and that you have to remove from the field and plant again, and then the trees that might permanently be along that buffer strip, you could do a lot to protect the interface between, say, the farm and the river, while also kind of coexisting with it and allowing, maybe then allowing the floodwaters to come in a more gentle way sometimes, because that's how all that farmland got there in the first place, was rivers flooding into those farmland and floodplain areas. There are some others that I like. That's one of my favorites. Also, reconnecting floodplains is a good one. So we with the River Smart Communities group that I work with, we talk about thinking about a river corridor within which it's really a good idea for us to stay out of harm's way, for us to allow the river to have that space to move around and migrate around. There's a lot of work on that in Vermont as well. And if we had less hard infrastructure in those areas and we moved back, but let the river move around in those areas, that's a good way to do it. And so similarly, I guess, related to that, where the river's going around, if you can find places to let water slow down and pond and seep into the ground, so like swales along roadways, disconnecting downspouts from houses. Everything doesn't have to pipe down and out and off really quickly. We can let it take its time, and the more it takes its time, that can be beneficial to your garden. If you want to let some water pond around in there, you can have little rain gardens where water's meant to pond and slow down. And that can mitigate some of the other effects like urban heat. You know, the more water's really good at absorbing heat. And so if you have more water around, things cool off and it's more pleasant to be around.
Thank you.
Sure.
Oh, that's related to this. Just this question, because I think it relates. How can we map the groundwater flow within our property, or like how would we be able to study that in our own homes?
Ooh, how do you map groundwater in your property? Where would you start? You could try to go on the Mass Mapper, which is really fun to play with. And so the Mass Mapper has a lot of GIS layers where you can go on and look at different data layers, and you can turn them on and turn them off. And that'll tell you a lot about surface water. Groundwater's a little trickier to figure out where you are there. Send me an email. We can look it up.
All right, back row, Scarf.
Are you seeing any effects from wildfires in the area, or what are they?
Oh man, good question. I'm a little bit terrified of wildfires actually, and that's a real concern. So we're, as you know, in a place that's highly wooded, which says to me that we have a really big, giant pile of fuel. And so if we have these significant droughts, I think that's something to be really aware of. And this past summer, we're still in a stage 3 drought right now in this region. It's not particularly dry right now, but we have this deficit of rainfall, and we're seeing the stream flows are down and the groundwater's down. And so when you have hot and dry plus those kinds of drought conditions, conditions can be such that it's more likely that you would get wildfires. And I think it's something that we haven't yet had to do anything like major defensible space, they call it, in places like California where they have a lot of wildfires, where you have to be cognizant of how fires travel through forests. But we have seen a lot more incidences of wildfires around the region, and I think it's something that is coming with those droughts with climate change.
Are you seeing effects of the fires in the form of flooding and runoff and a lot of water damage because there isn't anything to absorb that water anymore?
That is a fair question. That happens in places where you get the really big fires. So out west, they definitely see that. Again, California gets to be the guinea pig for a lot of these things, but where they have these really big catastrophic fires where literally everything is burned, and then you really have this bare hill slope, and you get a heavy rain on top of that. You see a lot of those impacts. I don't think we've seen that in the east yet, that kind of thing, because the fires that we get are much smaller in scale, and they don't tend to consume everything because it's much wetter here. Even when it's dry here, it's much wetter here. The gentleman in the beard, yeah.
So I'm curious, I heard you mention Atlantic white cedar and some of the restoration. I'm curious if you think you can do that on a large scale. Obviously, we had a lot more Atlantic white cedar. It might have been 20% of the overall forestry. But you need the hydrology. You're a hydrologist. I mean, you need sphagnum moss for it to germinate. How do you do that on a large scale when it's getting pushed out? You know, I mean, you've got sea level rise in the coastal areas where it does really well. And so there's no place for it to go, you know, and you don't have the right hydrology. How do you restore that?
Yeah, it's tricky. So I stumbled into these Atlantic white cedars through these cranberry restoration projects because
they're remnants, right?
Yeah, because they're remnants, and what we found was that underneath most of these cranberry bogs were a whole bunch of stumps of these cedar swamps because they had been these big stands of cedar. But so one of the first ways that we've been trying to do it is we said, well, hey, if these were Atlantic white cedar swamps before they were cranberry farms, let's plant a whole bunch of Atlantic white cedars. So we've been doing that, and many of them are successful. No, not all. You know, biology is a tough field because you have like 100 seeds and maybe one makes it. And we're trying to do better than that, but part of the reason why that is because the cedars have what they call this seed rain. They just start to throw seeds and throw seeds.
If the hydrology right, you'll get
and then you get one that sticks. And if there's varying hydrology, well then the trees are kind of hedging their bets by having a whole bunch of seeds, and one of them happens to be in the right place and they go. But when we plant them, we do a little bit better, and we can both we can plant a little bit bigger seedling so that it has a better shot at survival, but we can also plant it in a place that has the right hydrology, that happens to be in sphagnum moss already because we put some down or there was some left over. So for the cranberry bog restorations, I think we have a pretty good shot at getting some of these swamps back. But the tricky thing about cedars that I've been learning is that they're a disturbance tree. And so what they really like is a big hurricane to come and knock everything down, or a big fire to come through and clear everything else out, and then the sphagnum moss, and then the wet conditions, and then they'll just all grow up, and they're all the same size, and they grow up as like one big clump. But then in that forest, there's no baby trees. These aren't like mixed stage forests that kind of self-sustain. They don't work that way. And so you have to have enough of them around to have that seed rain going in there. You have to have the right conditions for that seed rain to land in. It's tricky, but one of the things that we've been thinking about with our Nipmuc partners are that we could actually have some Atlantic white cedar forests that are mixed age and a little bit more of a mixed age kind of forest. And the way we would do it is, since we probably aren't going to allow like a big long various river networks, and they can create a whole bunch of interesting kinds of habitat too. And so there's a lot of nursery habitat for fish and other creatures that can build up behind a beaver dam. Beavers in that way are kind of a keystone species in the sense that if you have a beaver and the beaver builds a dam, now you create habitat for all kinds of creatures that can thrive and live behind it. And actually we have a project coming up that I'm really excited about, where we're gonna pull out about 30 to 40 small culverts in one parcel and bring in some beavers and let them do their work and see what happens. Looking forward to that.
Thank you.
Yeah.
Yeah, just one more dam question, if I may. There's the term hydroelectric, which is massively built up around the world. I'm thinking of the Three Gorges Dam in China, our own Hoover Dam, the Aswan Dam, and so forth, right? And it's done mainly to generate energy for industrialization, right? But it's sometimes also described as an alternative to fossil fuels, right? So just wondering what your take is on all of that.
So this next dam question is about hydroelectric power. And there are these massive, massive projects for industrialization, and what is the impact of that, and what do I think of hydropower? So hydro dams, and particularly the kinds of dams that are large enough to generate a lot of electricity, are really terrible for river ecosystems. Because in general, again, organisms have a really hard time getting past them. Even if you have a fish ladder or some other mechanism to try to assist the creatures to get past those, they have a really hard time getting by. So it's very detrimental to the river ecosystem. It creates a lake, not a river, behind it. So that's a whole different kind of ecosystem than a river. And so that has its impacts too on the ecosystem. However, it turns out that hydropower, and particularly what we call pump storage, like Northfield, Mount Herman, is one of the most flexible forms of power generation that is really well suited to offset the other kinds of power made from renewable energy. So when the sun is shining and the wind is blowing, that's great. That happens in the middle of the day when the wind shuts off and the sun goes behind a cloud, or it's nighttime. You can click on the hydropower at the flip of a switch. It turns on immediately and it can supplement that power. And that balance works really well for renewable energy. So there's a trade-off, and it's not zero cost. Is it worth it? And if not, what else can we do to fill the gap? We need a lot more generation. We got to figure out a lot more in batteries. I mean, it's basically like a giant, mountaintop battery is what that is.
That's old-fashioned.
Maybe it is, and maybe we got to figure out the battery technologies on some sort of larger scale or something, or smaller scale, right? I mean, so maybe one answer might be to have that kind of battery storage on a really, really large scale, or maybe the answer is actually, no, wait, what if I just stored the power that I need at my house and I put it on my roof and then I take it into the battery and then that's enough and that's what I get.
Or in my car.
Or in my car, or whatever, but maybe larger or smaller.
All right, well, that is our time for this evening. So if everybody would join me in thanking So if you are interested, we are going to have another event. It's going to be right here on April 30th. I believe it's on April 30th. We'll double check that. But we're going to talk about AI and some musings on AI. So if you want to join us on April 30th, please do. If you're interested in visiting our website, you can use this QR code right here. And please, if you're not interested in our website, please do complete our post-event survey. We're always trying to make our events better. And so we'd love your feedback about what went well and what you think we could do a little bit better in the future. So thank you so much for coming.
Thanks, everybody.
Thank you.
Have a great evening.
Give that back. I'll walk out with it. Thanks for having me. That's so fun. This is awesome. Yeah.
I know it's test time. I didn't think I could sneak a question.
Yeah. Fire to rip through a big residential neighborhood and just clear out all the houses for the cedars to grow. Instead, we could be
That would take out your peat,
Oh.
and then it would take out your peat, that would take out your peat though.
Yeah, it would take out everything. So, but we could be the disturbance. So maybe in smaller areas, we could deliberately go in and clear out some limited areas and let the regeneration start to occur. And so do some kind of targeted regeneration in places where we want that forest to regenerate and be sustained, and kind of make it in a patchy way. And so this is kind of, we're trying to develop some models of co-stewardship and see what this looks like for both using the trees in the ways that are culturally significant for them and allow them to do that, which they can do under state and federal laws anyhow, but be targeted about it and work with them to then use that as an opportunity to allow those trees to regenerate in these targeted areas.
Thank you. I would just say though, fire, we need more fire. I mean, we have a lot of fire-dependent forest systems, and we're not system.
So if we need more fire to sustain those kinds of forest ecosystems, how do we do that with so many people around?
It's hard.
Yeah, it's tricky.
Well, you can do it, but just like you said, you can do it in other ways. You can allow some harvesting in some areas that opens things up more, and you don't move toward a certain series, group of species that are, that's what we're moving toward: red maple, yellow birch forest, where we don't have our oaks, we're losing, and you look to the coast, those pitch pine systems, they're all fire dependent systems. If you don't have fire, they have serotinous cones, they can't reproduce themselves. So we need some fire, but we don't allow it as a society. Just like we don't allow streams to leave their banks. So
Yeah.
I'll stop there.
Thank you.
All right, I know people have more questions, and I promise there will be one more opportunity, so hold on to your questions, and we're gonna get into our third vignette here. So you have your hands in a lot of different things in doing your work. So who all do you work with?
Yeah, I work with a lot of people. So the Atlantic White Cedar Project, we've been having a lot of fun with a bunch of different folks who are interested in that. So those are folks from DCR and from Mass Audubon and from Mass Forestry and endangered species, natural heritage and endangered species. Who am I missing? Well, Living Observatory is in that group too, and the Nipmuc group is with that, and Opacum Land Trust. Town of Monson was in there, and the Conservation Commission. Am I missing anybody? That's a big group, and that's been a lot of fun. In the cranberry bog restoration work, we've been working with Woodwell Climate Research Center and Mount Holyoke College, Bridgewater State, the cranberry bog program through Mass DER, Division of Ecological Restoration, and then the various towns where those projects are taking place. So that's Mattapoisett and Kingston and Rochester and Plymouth, all of these partners. With some of the river flooding, we've been working with the Massachusetts Department of Transportation. And so we do a series of trainings called Rivers and Roads with the Department of Transportation workers, because they're usually the first ones on the scene if there's a river flood. So we want to make sure that they are well versed in how rivers work and how to work with them. So that's been a lot of fun. That's a sampling.
Yeah, absolutely. So here's another big question.
Okay.
But can you speak about the relevance of land ownership, indigenous land ownership in communities, and rematriation efforts in your work, and in that, if you could define rematriation?
Sure. Yeah. So rematriation is the idea that we're returning stewardship of the ownership is the wrong word, which is why it doesn't quite work in the definition. But returning land back to and it's often called land back, also is another term that's used, back to the indigenous communities that had stewarded this land for several thousand years before we showed up, and did a pretty fine job of that. And so what's tricky about that is that, for example, we have our concepts of land are kind of all messed up when we go to try to do this. So the first place that we might go is we might say, okay, well, I own this piece of land. I'll just donate this piece of land back to the Nipmuc people. But if I do that, now the Nipmuc are going to owe taxes on that piece of land. And in order to pay those taxes, they might have to make some money and use the land as a commodity in order to make that money to then pay the taxes. So it's sort of the whole concept of what to do with a piece of land is really wrong-headed from their perspective in order to give it back. So ideally, this idea of rematriation is really not only saying, okay, here's this piece of land within which Massachusetts and the federal government are not going to charge you tax on it. We're no longer going to consider this piece of land a commodity in that same way. And then we're going to give you essentially sovereignty over that piece of land to do with as you will. And there's a lot of trust issues that come up when we try to do that, because some of us might say, well, what if they want to cut down trees on that land? We had it protected in all this period, over this period of time we put it in a land trust. Well, what have we done with a lot of land that was under, say, our jurisdiction over lots and lots of, we put up highways and we contaminated it and we cut down lots and lots of trees. So in some ways, like, who are we to say what they do with that land? But I understand the desire to also want to see it protected in the way that we want to see what protection looks like. And that's part of why with this project, with the netbook and the co-stewardship, we're really trying to define those things together of what does that look like from all of our perspectives in a way that we can work together to work towards that end goal of having this really healthy ecosystem. Because in a lot of cases, what it comes up as conservation is in some ways kind of neglect as far as they see it. And so there's a lot of nurturing of the land and taking care of it, removing invasives or stewarding it in a way that maintains it as a healthy ecosystem, pulling down some dead trees, and they can use the dead trees for various things, that maintains a healthy ecosystem and maintains the plants that are meant to be there in a healthy state. And so, but that's a lot of work, and all that work has to, again, thinking of it in a capitalist framework, be compensated in some way. And so, how does one do that work and value that work in the same way that we value other things?
Yeah, absolutely. Okay, so we're gonna have one final question from us, which is that you're really involved with Girls Inc. In the Valley, which is a nonprofit that helps girls and gender nonconforming students be their very best selves. Could you tell us just a little bit about what you do with Girls Inc.?
Sure. So I'm the liaison between Umass and Girls Inc. of the Valley for what's called the Eureka program, which is a 5-year STEM-focused college readiness program for female-identifying girls and scholars in between 8th and 12th grade. And so they spend 5 years in the program, which during the first 2 years, they spend a month on campus at Umass doing various STEM workshops with faculty or any other volunteers who want to lead a workshop. Some of you in this room have led workshops, I know. And the idea is to really give them that kind of exposure to exciting science and things that go on at the university that might allow them to feel like they belong at the university, that it's their university also, and inspire them to say, hey, this is really cool, maybe I want to do that, or maybe I want to do this, or maybe I want to do this other, but just exposure to all of these different ideas that they might not have gotten already, and to give them some confidence in those areas. It's a terrific program. And then they go on in the later years to work on college applications, and they can also have what they call an externship, which everybody else knows is an internship, which is a kind of a job readiness project. But that might be something they might spend a month in somebody's lab doing work there. So,
cool. What a great experience.
Yeah, it's terrific.
Yeah, that's awesome. Okay, well, we will open it back up. And yes, sir.
You mentioned earlier that heavy metals tend to be taken out of the water when impoundments accumulate organic material. And I was wondering about the mechanism of that. Is that a microbial or a sediment or plants or some sort of chemical chelation? And the second unrelated question is, I was wondering if you could talk a little bit about the effect of beavers on the waterways.
Oh, beavers, I love beavers.
Can I ask you to repeat the question?
Yeah, okay, so the first question was, what is the process by which the wetlands pull heavy metals out of the water? And that tends to be an absorption process, so the organic material, or the metals tend to react with the organic materials and absorb onto them and stay stuck to the organic particles is how that is. And it's catalyzed by the pH, the very low pH that tends to be in those waters. And then the second question is, what is the effect of beavers on waterways? I love beavers. So beavers also build dams. However, the fishies can make it up beaver dams, and there have been a lot of studies that have shown that the fish are not bothered by beaver dams and can make their way up through them. But they also pond water along various river networks, and they can create a whole bunch of interesting kinds of habitat too. And so there's a lot of nursery habitat for fish and other creatures that can build up behind a beaver dam. Beavers in that way are kind of a keystone species in the sense that if you have a beaver and the beaver builds a dam, now you create habitat for all kinds of creatures that can thrive and live behind it. And actually we have a project coming up that I'm really excited about, where we're gonna pull out about 30 to 40 small culverts in one parcel and bring in some beavers and let them do their work and see what happens. Looking forward to that.
Thank you.
Yeah, just one more dam question, if I may. You know, there's the term hydroelectric, which is massively built up around the world. I'm thinking of the Three Gorges Dam in China, our own Hoover Dam, you know, the Aswan Dam, and so forth, right? And it's done mainly to generate energy for industrialization. But it's sometimes also described as an alternative to fossil fuels, right? So just wondering what your take is on all of that. Yeah.
So this next dam question is about hydroelectric power, and there are these massive, massive projects for industrialization, and what is the impact of that, and what do I think of hydropower? So hydro dams, and particularly the kinds of dams that are large enough to generate a lot of electricity, are really terrible for river ecosystems because in general, again, organisms have a really hard time getting past them. Even if you have a fish ladder or some other mechanism to try to assist the creatures to get past those, they have a really hard time getting by. So it's very detrimental to the river ecosystem. It creates a lake, not a river, behind it, so that's a whole different kind of ecosystem than a river. And so that has its impacts too on the ecosystem. However, it turns out that hydropower, and particularly what we call pump storage, like Northfield, Mount Hermon, is one of the most flexible forms of power generation that is really well suited to offset the other kinds of power made from renewable energy. So when the sun is shining and the wind is blowing, that's great. That happens in the middle of the day when the wind shuts off and the sun goes behind a cloud, or it's nighttime. You can click on the hydropower at the flip of a switch, it turns on immediately, and it can supplement that power. And that balance works really well for renewable energy. So there's a trade-off, and it's not zero cost. Is it worth it? No. And if not, what else can we do to fill the gap? We need a lot more generation. We got to figure out a lot more in batteries. I mean, it's basically like a giant, mountaintop battery is what that is.
That's old-fashioned.
Maybe it is, and maybe we got to figure out the battery technologies on some sort of larger scale or something, or smaller scale, right? I mean, so maybe one answer might be to have that kind of battery storage on a really, really large scale. Or maybe the answer is actually, no, wait, what if I just stored the power that I need at my house and I put it on my roof and then I take it into the battery and then that's enough and that's what I get.
Or in my car.
Or in my car, or whatever, but maybe larger or smaller.
All right, well, that is our time for this evening. So if everybody would join me in thanking So if you are interested, we are going to have another event. It's going to be right here on April 30th. I believe it's on April 30th. We'll double check that.
Yes.
But we're going to talk about AI and some musings on AI. So if you want to join us on April 30th, please do. If you're interested in visiting our website, you can use this QR code right here. And please, if you're not interested in our website, please do complete our post-event survey. We're always trying to make our events better, and so we'd love your feedback about what went well and what you think we could do a little bit better in the future. So thank you so much for coming.
Thanks, everybody.